Hey everyone, this is Elspeth Dev and welcome to a tutorial series where we are going to take a classic game, The Legend of Zelda, which was on the original Nintendo Entertainment System, and we're going to break the game apart, understand the elements of it, and try to reproduce it in Game Maker. This is a great game, one of my all-time favorite games growing up as a child, and still to this day I love this game. I think it's a great game for learning a lot of the basics that you need to do for game development. So you have to do things like save states of the player, move the player around, deal with enemies, items, select menus, all sorts of stuff. So there's a lot of great stuff in this game that we want to try to replicate. And I thought this would be a good series. And as a part of the series, we're going to basically take one element every episode and try to reproduce it and just continuously build up the game. One note, for those that maybe are more beginners and aren't familiar with Game Maker, I'm not going to do an introductory to what Game Maker is. So if you don't know the difference between a sprite, a background, scripts, rooms, objects, if you don't understand those things, I encourage you to go check out another tutorial that goes over those basics and come back, because we're going to just get started doing coding. We're really not even going to do much of the drag and drop features of Game Maker, so we're going to get right into coding. So that said, let's go ahead and get started. And the first thing we need to do is create the screen. We're going to try to reproduce the screen almost as true as it is in the game. Let's go ahead and click start. And one thing I'm going to show you. The classic NES standard is 256 pixels by 240. But you'll notice the trees get cut off here. What I'm going to do for this game as we develop it is we're actually going to add the pixels that allow for that last row to show up. And actually, when we get to the dungeons, you'll see that the bottom gets cut off as well. So we're going to deal with that by adding the pixels. Instead of 224 pixels, we're going to use 240 pixels. So let's go ahead and jump into that. We're going to go ahead and create a room. And this is going to be a test room for now. So room test, and this is where we're going to test collisions and enemies and all sorts of stuff. So 256 by 240. Let's make the background black for now. And the grids that we're going to snap to for most tiles in the game, most objects, everything are going to be 16 pixels. For now, this is fine. We won't deal with any of the views or anything else. The next thing we're going to do is we're going to go to these global game settings. And because we're dealing with a pixel game, we need to go to the graphics and shut this off. Uncheck the interpolate colors, because as we scale up the screen, I'm going to show you in a second, when we click the green button to compile this and show the room, it's going to be pretty small compared to, where's the game? Compared to this. So we're going to scale this up now so they look comparable. This is actual 256 by 240 pixels on my computer, my resolution. So let's scale this up real quick. And the way we're going to do that is we're going to create an object. And this is going to be our object game. This is going to eventually be a controller that's going to save the states of the game. Where are we in the game? Are we in a level? Are we in a menu? So on and so forth. But for now, this is just going to deal with this part of scaling up the screen. So what we'll do is we'll create a variable called scale, so we can change this later if we want. Actually, probably 2. And the way we scale it up is we say window set size, and you add the height and width. So we'll go ahead and get the window get width and multiply it times the scale. And we'll do window get width, height times scale. And this, we're going to make this object persistent, which means eventually when we actually start using this, if we change rooms, this object will always be there. So it's always going to be persistent. So now this should be of a comparable size. I forget how big I made this right here. Okay. Oh, classic mistake. You got to actually add the object to the room for it to work. So we added that. And here we go. Okay, they're of similar size now, as you can see. So the difference is the width is exactly the same, but when I line these up, you'll see I have those extra pixels here because I'm using 240. So that's a good start. So the next thing we're going to do is create the player movement. And so I'll grab my controller. The basic movement is Link goes left and right, and up and down. And one thing he can't do is he can't go diagonal. You can't tell what I'm pressing here, but I'm moving my control pad around and he never goes diagonally. So we're going to try to reproduce that real quick. And the way we're going to do that is we're going to create a quick temporary sprite called sprite player. We'll edit that sprite, create a new one. Link is 16 pixels, so by 16 pixels, so we'll do that. Now later we're going to put in real pixels that represent Link, but for now all we need to do is create like a box to move around. So we'll create a little red box. We're going to change the origin to the center so that when I'm messing with the X and Y coordinates, I'm dealing with the center of the object. Okay, we got our player sprite. Now we're going to create our object player. Assign that sprite to him. Great. We'll add an event, or we'll do a create event. And in here, let's do, I think there's 3 things I want to store now, which is the X movement, velocity. And so right now we'll set it to 0. The Y velocity is 0, and player speed equals 2 for now. And then let's add a step event. And what we'll do is, let's go ahead and, I think what we need to do is go ahead and create, we'll do the code here. We'll do, we'll check for the left, right, and up, down buttons. We're going to change this in a little bit, but we're going to do a keyboard check, virtual key, left, right. And so let's do that with every one of these. Left, right, up, down. Up. And down. And so we're going to do a trick that I've seen in several videos. I couldn't even tell you who to credit for this. I honestly can't remember, but I've seen it before, where we're going to do a little trick of, we're going to make the velocity of the X equal to checking whether or not is it left minus right? Times player speed, and then Vy equals down minus up times player speed. And then all we'd have to do right now is say X is plus equal to Vx and Y is plus equal to Vy. Okay. So let's check this out real quick to see if this works. And what we're going to do is add the player here as an object and see if that works, and then I'll try to explain the code real quick. Yep, I had it backwards. Only on the left and right. So I'm pressing left right now, I'm pressing right, and I'm pressing up and pressing down. So I messed something up. But one thing you'll notice, I said earlier that Link doesn't do diagonals. So we're gonna fix the left and right at least. Yeah, it should have been right and left. Yeah, okay, so what's happening here is when you do a keyboard check here, what gets stored here is a 0 or a 1. If the player is actually pressing the left key, this will equal 1, otherwise it's 0. And so when we do the math here, if the player's pressing left but not pressing right, it's going to equal to -1, and we're going to multiply it times the player speed, which is 2 in our case. So this is going to be -2, and that's going to tell it to subtract 2 to x every time that's getting pressed, which is going to move them to the left. Otherwise, if it's this is equal to 1 because he's pressing right, but he's not pressing left, so it's going to be 1 times that. So +2 is going to move him to the right. So the same thing goes for the up and down. So that fixes at least the mistake I made, where now when I press left, he goes left. Now when I press right, press up, press down, but still got the diagonal. So we'll do a quick little trick on this one too, where we're going to check to see if one of the other directions is pressed. Basically, I'm going to say if the player is already pressing up or down, then we don't need to check the left or right because he can't press that. So what we're going to do is, in this case, we're going to say if the absolute value of Vy is equal to 0, then we can check this. That's basically saying if the up and down button is not pressed, then go ahead and check to see if the left or right is. And we do the opposite for this. So if the absolute value of Vx is equal to 0, then you can check the up and down. And that should give us no diagonals, which is going to be really hard for you guys to see. But as I press around on the keyboard, you're going to see that he never goes diagonally. So I'm pressing multiple keys at the same time. Never goes diagonally, only left, right, up, and down. So that fixes that. And now we have a movement that's a lot more like how Link is moving here, which is up, down, left, right. Okay. So the last thing we're going to do here to get this basics done, and this is kind of how the tutorial is going to go. We're going to just build on this in the next episode, but I want to create an input object so that I don't have to rewrite my code later when I decide to add gamepad controls or change where the keys are. Right now I'm using the up, down, and left arrows. So we're just going to create an input. And for some reason, my preference is when I do an input object, I don't put the obj in front of it. That's my preference. And what we'll do is we'll go ahead and create, and what we're going to do is set up variables and make them all false. For up equals false, down equals false, left, right. In the case, since we're replicating the NES game, there's not a lot of buttons, so we're going to go ahead and set select equals false, start equals false, button B equals false, and button A, I should have did that in the other order, but equals false. And so this is going to check for all the buttons. We'll probably add some more buttons here. So there is a difference in Game Maker, or in general, is you want to check whether or not it's pressed once and only once. So even if they hold it down, you only check once, or if it's being pressed constantly. Right now we care about the constant presses. So we're going to set these up, and in the step event, we're going to constantly check for these pressings and set those. So in this case, we'll say we're going to take the code we had in the object player, we're going to move that here. So now we're moving all the code for actually checking left, right, up, down to here. And then what we can do is say input dot right, input dot left, input dot down. So this is nice because later when I do add the controls for the gamepad, I don't have to change my player at all. Now it's just going to work, and I'll make the code in here actually check for both. Okay, so this isn't going to work yet because the the room doesn't have this object, but what we're going to do is we're going to instantiate that as a part of the creation of the game controller object. So what we're going to do is say instance create input. So we'll go ahead and create that instance. And we're going to create it at, that's right, we have to put it at 0, 0. And we're going to make that persistent as well. So it always stays within the game. So that's one thing that we'll always need in the game. So let's see if this works. Still, the code should still work. This is a good time to see if there's any bug fixing we need to do. Now, so it still does work even though I took the keyboard checks out of the actual player object and moved them to the input. This is going to be helpful as we start organizing our code later and not trying to deal with always checking keyboards and just using the input to see what's been pressed. So I think that's all we're going to try to get done today. I think next time we will probably try to deal with sprite changes as you press left, right, up, and down. Link's sprites will change. He's going to be facing left, and he's going to have some kind of animation. If he's facing up or down, he's going to have the same thing. So deal with that and potentially start getting into some collisions, putting some walls here and stopping the player movement. As we progress, we'll start adding enemies, and then what do the actual graphics look like, and screen transitions, and so forth. So hopefully this has been helpful, and you're learning something, and I will see you next time.